Welcome to another episode of Cool DIY Projects. I'm Maker Brianna, and today we are going to make a Bose Speaker Cube.
Okay, so what are the components of the BOSEbuild Speaker Cube? Brianna, can you take us through it?
So this is the speaker.
Mm-hmm.
This is the circuit board.
Okay.
This is the case for the speaker cube.
Okay.
This is the design thing. This is the clasp to hold it together.
Okay.
This is the power supply. That's the magnet, and that's the coil.
So that's a magnet and a coil that we're going to use to demonstrate how a speaker works. And what's the last part of it?
My phone.
Your phone. And it has to be apparently an iOS device, not an Android device.
Yes, that's very important to know.
Okay.
Very important.
Before we begin construction, Brianna, can you tell us a little bit more about the circuit board?
Well, one thing is that it's already built, so you don't need to solder or anything, which is kind of sad.
Oh, okay.
The second part is that I can talk to my phone through Bluetooth,
Okay.
and that the audio amplifier goes to the speaker.
Okay, so it's got a Bluetooth receiver for talking to the phone. That's how you send music to it via your phone. And then it's got an audio amplifier for driving the speaker.
Mm-hmm.
So the first step is to plug the power supply into the circuit board, which activates the Bluetooth, and then we should be able to connect it to your phone. Go ahead and plug it in. Okay.
It's the blue thing is on, and there
Okay,
you
now
go.
select BOSEbuild Speaker Cube. And now you're connected. The next step is to download the BOSEbuild Sound app from the iOS App Store. So just look for BOSEbuild on the App Store and then click the little down arrow to download it. Go ahead, Brianna. So that'll download and then we'll be back. So we downloaded the app and we ran it, and what's the first thing that happened, Brianna?
The first thing that happened is that it asked us about the software update.
Okay, so it's saying that there's a software update available and we need to hook it up to our computer and do a software update. So we'll do that next. So what are we doing now, Brianna?
So we hooked up the USB cable, and now we're doing the update.
So we've updated the circuit board with the latest software. What's next, Brianna?
Basically, the app is going to walk us through the steps of how to build this speaker.
The first step is to learn how a speaker works, and we're going to do that by looking at the basic components, the first of which is a magnet. Brianna, can you show us the magnet? Okay. And what does a magnet do?
It attracts certain types of metal.
Okay, you think we can find a metal that it attracts and then one that it doesn't?
Mm-hmm.
Okay, show us.
Here's one.
That's a letter opener. Go ahead and put that next to the magnet. Does it attract? No, doesn't look like it. What about the scissors?
Maybe.
Oh, there it goes. So we found that it attracts some kind of metals and not others. Another component of a speaker is the coil. Brianna, can you take the coil and put it over the top of the magnet?
Mm-hmm.
Okay, do you notice any attraction between the coil and the magnet?
No.
Okay, so why is that?
It's because that copper is non-magnetic.
Copper is non-magnetic, right. Next, we're going to hook up the coil to the control panel. Brianna, go ahead and hook it up. Okay, and then we're going to send an electrical current through the coil and see what happens. Okay, Brianna, let's tell the app to send a current through the coil and see what happens.
Okay.
3, 2, 1. Boom. So why did the coil jump off of the magnet, Brianna, when we sent a current through it?
Because when the current goes to the magnet, it acts like an electromagnet.
Can we control how strong this electromagnet is, Brianna?
Yes, we can.
Show me.
If we have a little bit of power, it doesn't really jump that high.
There's just a little tiny jump there. Now what happens when you turn the power slider all the way up?
It gets a big launch, like this.
Okay. So we've seen what happens when you put a current pulse through the coil. It causes it to jump off the magnet. Can you show us what happens if you put a time varying current into the coil?
Yes, I can.
That's interesting. So the coil is going up and down according to the frequency of the waveform. Can you turn up the frequency? Turn it up some more. Okay, can you control the magnitude? How much it's going up and down?
Yes, I can do that.
Okay, look at that. So Brianna, we found out that if we put a time varying current into the coil, that the coil would vibrate according to the frequency and the magnitude of that current. What do you think is going to happen if we put a audio frequency current into the coil, say like 700 cycles per second?
Well, you see, we can hear it, but we can't really see it because it'll be moving too fast for our eyes to see it.
Okay, so it's going to cause the coil to vibrate so quickly that we can't see it, but because the tone is in the audio frequency range, we should be able to hear it.
Yes.
Okay, let's try it out and see what happens. So I didn't see the coil move. Did you see the coil move?
Uh-uh.
Did you hear it?
Yes.
Okay. So that was interesting, Brianna. We couldn't see the coil moving, but we heard it vibrating at that 700 hertz frequency. Why is that?
Because the coil created vibrations in the air.
So the movement of the coil caused the molecules in the air to vibrate, and those vibrations propagated through the air, and when they got to your ear detected those vibrations as sound. If we want to get more sound out of our makeshift speaker system, Brianna, what do we need to do?
We need to create more vibrations in the air.
Right, and one way of doing that is to tape the coil to something with a larger surface area like this piece of cardboard, and then when the coil vibrates, it's going to vibrate this entire piece of cardboard, which is going to move around a bunch of air molecules. Let's try it out. So we're putting an audio frequency waveform into the coil, and Brianna is loosely holding the piece of cardboard so that it can vibrate, and now she's going to take that magnet and get it close to the coil. Go ahead. You can hear it vibrating. Now watch what happens when I grab the cardboard. It's louder when I'm not holding on to it. And when I touch it, I can feel it vibrating. Now watch what happens when I change the frequency. So essentially what we've done here is make a primitive speaker. So what are you doing here, Brianna?
We cut out this piece of paper and tape the coil and the magnet to it. And we are going to fold over the coil
Onto the
magnet like this.
And so when the coil vibrates, it's going to vibrate that whole piece of paper, right?
Yes.
And what's that going to create?
It's going to create vibration.
Right, it's a paper speaker. So the paper does two things. First, it holds the coil over the magnet in just the right way so that the coil can vibrate. And what's the other thing that it does, Brianna?
It increases the area of the coil.
It increases the area of the coil so that when it vibrates, it pushes more air molecules around. Let's see if we can get some sound out of our speaker. Pretty cool, huh?
Yep,
What you holding in your hand there, Brianna?
the real speaker.
The actual speaker that came with the kit. Can you show us the 3 basic components of the speaker?
So this is the magnet.
Magnets right there.
This is the coil down here.
The coil's down in there. It's kind of hard to see on camera. And show us the front. What's on the front there?
This is the cone.
The cone. And what does the cone do?
The cone is like the paper on the paper speaker.
Right. The cone is what basically pushes the air molecules around, which enables us to hear the sound caused by the vibration of the coil and the magnet. So we've attached the speaker to the control panel, and we're going to see if we can get some sound out of it. Go for it, Brianna. Okay, pause it. So a couple things we noticed. One is that it plays a lot louder, Brianna. Do you think it sounds better than our paper speaker?
Yes.
It does, right? So they've done some design enhancements over our simple design, which enable it to sound better. What do you say we get this thing built?
Yes.
How's construction coming along, Brianna?
Good. I have clipped on all 4 sides, and now I am going to secure the speaker.
Okay. They just go on with these little snaps. They're a little bit tough to get on. You have to have a little muscle. So I'm going to let her finish snapping on the speaker and we'll be back. So Brianna attached the speaker and we flipped over the speaker cube, and now she's attaching the control panel to the back. Everything goes together with these clips, so if you've done Legos before, you should have no trouble putting this together. So Brianna's completed construction of her speaker cube, complete with dancing lights and some attractive side panels that she put on there. You ready to give it a try?
Yes.
All right, let her rip. Pretty cool, huh? All right, we'll be back shortly with some final thoughts. So do you think that this is a project that anyone can build, Brianna?
Yes, there was no soldering involved.
Yep, so once we got to the actual construction, it didn't take that long. No soldering, really no tools necessary. What about the fun factor? All right, so what's your final words for your audience?
I'm Maker Brianna, and thanks for watching.